So what I'm going to do is just highlight the data that I want to visualize, and then hit Chart. It should be one of the tabs up here, or you could go get it through one of your Excel tabs. I'm going to say, give it to me in columns. And then, or you could use bar as well. That, in Excel, it just means it's on its side. But I'm going to use columns for now. And I'll just pick the first one. It seems the simplest. Voila! Here is, I'm just going to delete that legend. It's redundant. Here is my frequency table. And we could see, literally see our data. And it also tells me what each of these bars stand for. It stands for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, what Excel will do is it'll automatically seed your x-axis with just those numbers. Starting from 1, it'll go up. Now with months, handily, that is the same thing that Excel is doing, right? But in other examples, we'll need to put in our own x-axis. Notice that here, these are not means, they're not averages, these are frequencies. This means that 7 people are born in January. 10 people are born in July, right? 7 people are born in December, right? And so that's what our birth month frequency visualization looks like. This is our frequency distribution for birth month. Now, let me minimize this. So is the number of friends born in a particular, is 1 month particularly popular for when our friends are born? It doesn't really seem to be the case. The months all tend to be from something like 7 to 10 people per month, right? And so it seems that the number of births are fairly uniform. Let's go into our second example. So here's another example. Now let's take our same data, the data from 100 Facebook friends, and we're going to look at what is the age distribution in this sample. Here's my Excel data. I'm just going to click on the data sheet. And here, when we go up and look for age, we could see, oh, okay, here's a whole bunch of ages. It sort of seems like there's a lot of people in their 20s. Yeah, maybe a few people in their late teens. But here we see some people who are 0 years old. Actually, in this data set, if they have a 0, it means that they didn't list their year of birth, or they didn't list their age. Maybe they're embarrassed. Maybe they're too young. I don't know. All right. But we don't really learn a lot by just scrolling up and down on this data, right? That's why it'd be nice if we could look at a frequency table or look at a distribution visually. So now I'm going to click on my age sheet. And here I've already set it up so that we could just do a frequency table really easily. From the lowest age in our sample, which is 17, I've ignored the zeros, obviously, to the oldest age in our sample, which is 38. And there's all the ages in between. So let's go ahead and put in our formula to find out how many people in our sample are 17 years old. So to start a formula, we start with the equal sign. We use count if, because we don't want to count everybody. We just want to count the people who are 17. And let's tell Excel what our, where it should find our data. What's the range of data? So I'm going to click on data and click from this cell all the way down to row 101. Here we go. And I know I need a comma after that. Oh. And I'm going to delete that part. All right. So here's our data range, and I wanted to count it if this person is 17. And my inputs there. Now, remember, we want this data to stay the same all the time. We don't want it to move because Excel will move it if it has the chance to. So I'm going to put dollar signs in front of the L and the 2, in front of the column indicator and the row indicator, to tell it to lock this data in place. Always use this data. Don't change. Don't change. Stay the same. All right. Once I have that formula, I'm just going to drag it all the way down so that it counts up the frequencies for 18-year-olds, for 19-year-olds, for 20-year-olds. But let's spot check. Let's look at 21-year-olds. It says count if our data set has stayed the same because we've locked it in with our dollar signs. And now it's saying, oh, count these people if they are 21 years old. That's our criteria. So it looks like our formula has copied and pasted quite well. Notice that for some of these ages, the frequency is 0. There are 0 people who are 26 years old in our sample. Now, why do I want to keep that 26 in there? Well, if we skipped out on 26 and 28, 29, 30, 31, 32, and we looked and saw that, oh, look, there's one 27-year-old and one 33-year-old, we might mistakenly assume that from 27 to 33, there's equal chance of having at least one person from our sample being sort of in that range. But you could see that, oh, that's actually not true. In between there's like a big desert of nobody. And we want our distribution to reflect that. Age is a continuous variable. And so we don't want to skip any ages. We want to show how the distribution looks as we look at age continuously. All right. So this is nice because we could already see that the ages are sort of clumped or clustered around age maybe 20 to 22, so early 20s. But it'd be nice if we could really look at this. So one thing you might want to do is click on, select both age and frequency, go to charts, and we're going to do an XY scatter. For those of you who have Microsoft Excel later than 2008, so like 2009 and later, you could go directly to column. But here we're going to start with 2000. We have 2008 Excel, so we're going to need to do a little fix. So first I'm going to click on a scatter. A scatter is nice because it shows you both the age, so this is age 17, and the frequency, right? And once we have that, then I'm going to go to column, and then it'll show me, oh, 17 through 38. Now, if I had gone directly to column, here's what will happen. If I didn't go through scatter first, here's what will happen. So let's say I just wanted the frequencies. If I go directly to column, it won't give me the proper ages on my x-axis. It'll only give me Excel's default setting for the x-axis, which is just labeling it from 1 all the way to 22, however many there are. That's not what we want. Instead, we'd rather have Excel label the correct ages for us. And just so that we'll know that this is a frequency distribution of ages later, we should go and label our horizontal x-axis. We could label that age. And that way we'll know it's a frequency table, but it's a frequency table of ages. That's what the 17 stands for. All right. So what's the age distribution in the sample? It's largely young. They're mostly on the young side, with a few people sort of in their 30s. All right, example 3. Again, from our same Facebook data, what is the height distribution in this data? What do their heights look like? Well, let's see. If we click on data and we look at their heights are listed in inches. Remember that 5 times 12 is 60, so 60 inches is about 5 feet tall, and then 68 is 5 feet 8. That's a quick way to think of it. 72 is 6 feet tall, so that person is pretty tall there. But once again, if we just look at these row by row, it's just a bunch of numbers. We don't need that. We'd rather have a nice frequency table. So let's go to height. So I've already seeded it for you with the height, that's the minimum height in our data set, as well as the maximum height in our data set. The minimum height happens to be a little bit just shy of 5 feet, so 4 feet 10. And this one is a little bit more than 6 feet tall, so 6 feet 3. So let's put in our frequency function. So count if, and let's go ahead and select the data that we want to use. And now that we know we basically need to lock it in place, let's do that. Let's do that right here. So let's lock it in place. All right. So we've already locked our data in, comma. And what's our criteria? Well, I want you to count it if they're 58 inches tall. So it seems that there's only one person in our data set of 100 that has that height. And I'm just going to copy and paste that all the way down. Once again, I'm just going to spot check 69 inches tall. Count if this is the correct data. It's locked in. And this is the correct criteria that I want it to use for that row. So good. When we look at this, it seems that it's not that there's one cluster. It almost seems like there's this sort of giant spread out cluster, right? It'd be nice if we could look at this visually. Well, let's go ahead and select both columns. Go to chart, and go ahead and select XY, scatter. And this is going to give us both, it's going to use the height as the X coordinate and the frequency as the Y coordinate. So here we see that all our frequencies are up here because all of our heights are from 58 to 75 inches. And let's change that into a bar chart, or a column chart. All right, and here's what our distribution looks like. And just in case we come back to this later, it'd be nice to know what these numbers down here represent. So I'm going to go to my formatting palette. Let me close that. I'm going to go to my formatting palette and tell my horizontal axis that it should be labeled height in inches. Let me move this. And so that's what our distribution of heights looks like. It looks like there's these over here. This one seems pretty popular, and these seem sort of popular, right? These are less likely, right? This one's a little bit less likely. So this is sort of what our shape looks like. And it's nice and it's really easy to see when we see it in a visualization. It's harder to see when we just look at the list of numbers.